Greetings, everyone, online and in person. Um, I hope everyone is warm and dry. We are in the process here in at Horicon. It's going to be a cold, windy, snowy night. I don't know how your winter has been in New York there, Andrew. It's been mild. I know they had a lot of snow early, so hopefully
Yeah,
you survive that.
we survived. We did okay. New Yorkers, Manhattanites don't do very well with snow. I'm happy that I spent a lot of time upstate, so I know what to do, but a lot of people don't.
So recapping things here at the center, we are getting ready for our annual candlelight hike that's taking place this Saturday. I will be out on Innermuley Island talking owls in the dark for about 4 hours or so. And if you'd like to stop on out, say hello, I would appreciate it. So that's one thing going on. We did have a winter bird bus trip, which filled up right after Christmas. So we doing that. That's there's no. I'm sorry, but there's no more tickets available for that. We already have a bus load. We have coming up on March 7th will be our nest box seminar. We'll be covering in that nest box seminar, we'll be covering, I'll be covering wood ducks. Liz will be covering bluebirds. And this year we always try to rotate through other cavity nesting critters. This year we're going to have someone from the bat conservation. So they're going to talk about bats and bat boxes and where to put them and how to monitor them. And so it's a little something new, something new that you can, an easy thing that you can do around your property to enhance wildlife. So for those that get the Wisconsin Natural Resources magazine, pretty tickled. I had a article in there on wood ducks and how to put up boxes and how to monitor them and do's and don'ts and tips and tricks on there. So I do have some spare issues if you want to take a look at it, but it's also online. So you just go to Wisconsin Natural Resources magazine, and then it's the winter issue, and then scroll down on that, take a look on that. So I'm pretty tickled and happy that I finally put together in one place where I had everything that you pretty much need to know that will make you successful or make your boxes productive. So, just a couple. It's been sightings here. Have been kind of slow. Nothing new and amazing. Oh, I did have a northern shrike the day before yesterday around my property. Um, we went to look for some local short-eared owls that we had in December, and we did not see them. That was down in the Ashippun areas. They still could be around, but nothing there. Um, Red-breasted nuthatch is about exotic as we had. Oh, we did go Astrogo County Park. We had tufted titmouse down there and a yellow-bellied sapsucker. So that one was enough to I had to fill out some paperwork for that one. As far as got designated as a rare bird, which is yeah that we don't have them wintering here too often. So that was a nice bird to see. Um, Anybody else here from the crowd have anything that they've seen? I know some folks here have were on the WSO trip out of Milwaukee. Yeah. Oh, they had a mute swan, some scoters, white wing scoters. Yeah. Oh, you had some longtails, huh? Yeah. So those are, yeah, longtails are kind of a cool bird. Well, they're definitely a cool bird, but a lot of times they don't come near shore all that often that you can get real good looks at them. So that those are always a special treat. So with that, um, we have any sightings from our online particular audience, any of our local folks? And if not, um, we can revisit those later. So with that, we're gonna jump into our speaker. Andrew Farnsworth has been with us several times. He works with the Cornell Lab of Ornithology. Um, and it's always it just kind of sends shivers up and down my spine what Cornell Lab is always working on, what is new, what they're finding, researching. um, um, you know so so the title of his presentation is "What's New in Bird Migration." They fly back and forth, right, Andrew? I
They
mean,
do. It's not that new. Sorry.
yeah. So um, so with that, we're going to turn it over to Andrew.
All right. Well, it's nice to be here with you all again. Thank you for having me back. And tonight will be a little different than the presentations previously in that it's been a while since I've assembled a fully new presentation of just things that are kind of on the fringe of what we've been working on or right on the cutting edge, and also what some of our friends and colleagues have been working on, and just some patterns that we've been seeing. So I'll talk about a bunch of those different things tonight. Some of the information I'll talk about has been published, some of it has not, and some of it's not really even under investigation beyond sort of exploration. So there's some really new stuff here, and some patterns you probably you'll recognize some things for sure. And if you followed BirdCast for a while, you'll probably see some things that maybe you've seen, but there's some new stuff here too. So let me get into it. You guys can be the guinea pigs for it. Let me know how it goes. I do always like to start out with just sort of why, and why birds are important. And I like to highlight this. This came from a paper from a few years ago. I like the imagery. I like the simplicity of the message, sort of thinking about why birds are important and why we do this and why we talk about this and why we're here. And that is both a very much a functional ecological niche and components to ecosystems and participants in this global system, as well as the parts of birding that are about why we have the passion for it, these iconic and striking and beautiful things for the aesthetic values, the conservation, the stress reduction, all of those things. So it's just always a good thing to keep in mind. And so let's just jump right into some of the new stuff. Okay, so I like to think of one new thing that happens obviously every migration season with BirdCast and just generally is that we never really know exactly. We can forecast very well, I've told you about that before, but we don't really know how necessarily a migration season is going to go when we sort of zoom into the scale of what's exactly going to happen tonight. We know it may be a very large migration, and we know that some seasons we see these incredible movements, and some maybe not so much. Maybe they're distributed over longer periods of time. Pulses happen at different times. Maybe the total number of birds that migrate, say, over the U.S. every fall is always about 4 or 5 billion birds. But how that process happens is something that's new. And I like to highlight that this past season, we had an absolutely massive night of migration, this 1.25 billion bird night. I mean, thinking about something close to like 15 to 20% of the total migration traffic that passes these transects on the Canadian border and the Mexican border, traveling aloft one night in October was it's just kind of mind blowing. And so one of the things that I like to think about that's new is even presentations like this, just simply the magnitude, not even knowing what the upper limit is on a night. This was a record for BirdCast so far. We haven't had a night in our recorded history that was this large. What does that mean? Does it mean bird populations are going off the charts? Does it mean that the distribution in time was different? Well, we're still figuring that out. I suspect it's about the distribution in time, and it's about the set of conditions that kind of brought this about. Some of you that may remember the fall probably remember there were a couple of incredible periods where massive cold air masses arrived into the US maybe a little bit earlier than usual. And this happened to be one of those really big high pressure system. And it begat this incredible movement of birds, in particular in the eastern US. So I like to highlight from, even though it's a presentation you've seen before and something that shows up all the time on the BirdCast site during migration seasons, this level, this magnitude was something very new. Let me dive in deeper and think about some other new stuff. So last time we spoke, and some of the other times that I've presented recently, one of the things that often comes up from the radar perspective you just saw, uh, we don't know what those species are directly from the radar. But we do have other methods for studying what's actually migrating as it's migrating. It's one thing to, of course, go out and go birding during the day and see where birds have stopped over and where they're feeding and so on. But it's another thing actually to monitor what's happening at night. And I'm sure you've heard me talk about flight calls before and monitoring nocturnal migration to species level. Um, and and the use of acoustics and monitoring flight calls has come a long way in the last really 5 to 10 years in particular. So now we're finally at the place after, boy, what seems like an eternity for me, certainly since the early 90s of constantly saying like, yeah, we're almost there. We're almost to the point where we can do automated monitoring. And another year goes by, and another year goes by, and we encounter another issue. And finally, really over that past 5 to 10 year horizon, a couple of major nuts cracked. Hopefully, a lot of you use Merlin and know what Merlin is and the sound ID component of Merlin. That's underlying some of the mechanisms we use to do work like this. And one of the things that's new in terms of not only just being able to study nocturnal migration from the acoustic perspective in a way that we can do it almost in real time or close to it, is that we can start to analyze these data finally in a number of different and really interesting ways. It becomes more, I mean, it's powerful enough for me anyway to be able to say, oh, okay, well, there were this many rose-breasted grosbeaks and black and white warblers and white-throated sparrows and savanna sparrows and black-throated blue warblers last night. It's another thing to be able to say, well, what kinds of relationships are we seeing in the data that are kind of indicative about where birds are over the course of the night traveling seemingly together, or at least in close enough proximity that when we record their flight calls, we can think, okay, there may be some kind of a relationship here, and we can start to study those sorts of patterns of, what birds are most likely to occur with others. Kind of thinking about these migration waves that we see all the time when we think about going birding in a particular marsh in the morning or patch of habitat or anything like that. And on a nice spring or fall morning, when there are lots of birds around, at a particular point in the spring what kind of a wave of migrants will be there, sort of what the diversity will be, what species you expect in April versus May versus September or October. And we're starting to be able to look at those kinds of assemblages now at night and think about what kinds of relationships exist. Do we see patterns where there are relationships, say, white-throated sparrow on the right side of this image? You'll see a green dot in the middle there, WHTSPA, the 6-letter code for white-throated sparrow. And that that flight call, when white-throated sparrows are calling, are often associated with white-crowned sparrows, savanna sparrows, as you might expect, terrestrial, songbirds that are traveling together, but also with a couple of other interesting species like common yellowthroat, not sparrows, obviously, palm warbler, also not sparrows, but these kinds of family associations and species associations that start to be sort of the next stage of thinking like, okay, what's causing these? Like, yes, there's a pattern we see of of the particular timing of migration related to from where birds are originating, the destinations to which they're going. But there's more than that too, in terms of sort of the social interactions that are happening and the kinds of patterns we see when we hear or record one species, what's most likely to be around it. So this is a cutting edge element. This paper was published, Benjamin Van Doren's the lead author. It was published earlier this year, and I think it's absolutely going to be the absolutely going to be one element of the future of the kind of work that we see coming out, where we think about co-migrations, not just about a particular species migrating in space and time and what its needs are, but also other species that are migrating with it, and kind of thinking about what does that mean for monitoring, for acoustic communication, for the evolution of migration systems. Really, really kind of fascinating stuff that this whole process of acoustic monitoring, now with machine listening and artificial intelligence and cloud computing and better kinds of gear for monitoring, all of that is unlocking right now. So very, very cool cutting edge direction to proceed. From another kind of methodological approach, you probably also have heard me talk about another component of monitoring birds at night. Again, sort of this, no pun intended, black hole for studying birds. All sorts of challenges with seeing migrants as they're moving and identifying them. And so, along with the acoustic monitoring, we've also been doing some work with thermal imaging, and in particular, thermal imaging related to then using cameras to document what's happening at night. So in this case, this was a really cool study that's just about to come out that paired the use of actually acoustic monitoring technology, like you just saw, with thermal imaging cameras, and then also photographic cameras, like SLR type units, just things that you might you photograph during the day. This kind of an approach that we started to develop to understand, all right, can we actually document what's happening at night with some very specific use of thermal imagers, with a searchlight occasionally, localizing a bird, then very quickly taking a photograph of it. Really, really cool way to do a number of things that are kind of going to be groundbreaking. Some of it is just identifying what the species are. So in this case, these are both images of a magnolia warbler photographed in Cape May a couple of falls ago. And the idea that we can use the thermal imagers to localize where birds are, then very quickly get a quick light on them, and then photograph them to document what's there, understand how high they are based on the resolution of the photographic image, and sort of kind of troubleshooting those images based on test cases during the day, corroborating what we see there with what we see at night. Very fascinating way to kind of unlock a little bit more about the mysteries of nocturnal movement. So another technology here that's going to be evolving is this kind of the use of thermal imagery, but also even just direct use of cameras at night, and figuring out how to do that. And again, enhancing our understanding of what's migrating when. One of the particularly incredible options and opportunities for doing this kind of work, I think, is going to come actually outside of the US. And in the US, as you probably heard me say, we have a pretty reasonable understanding of what's migrating where and when at night, even if we can't always see it directly. We have a lot of ancillary information to connect the dots. But in other parts of the world, we really don't. And there are places, for example, in Eastern Australia, where we're just learning with radar that there are significant migratory movements that are happening at night. And people are hearing birds migrating at night, but they have no idea what they are, because there's never been very much consistent or intense study of flight calls of birds in Australia. There has certainly not been much comprehensive study of even just nocturnal migration there. So the idea that we could use a technique like this in conjunction with the other to start unlocking, well, what family of bird even is that? Because some of the calls are extremely common, but even the most expert birders in Australia don't know what they are, which is a pretty incredible state to in which to exist. And I hope to be able to employ some of this there at some point soon. Really, really fascinating, fun stuff. All right, digging a little bit deeper into those methods and sort of what's coming and what's new. So you'll remember discussions about extensive light pollution, a little different from the really localized flashlight that we're using to spotlight birds and get those quick photos. We're talking about extensive light pollution from human infrastructure, whether it be cities or greenhouses or energy infrastructure, and how that impacts birds that are migrating at night. And for a number of years now, we've been monitoring in many places around the US at the Tribute and Light 9/11 Memorial in New York, also in other parts of in Texas quite a lot, and in other parts of the states as well. And one of the things that I like to constantly check on is kind of the new elements of migration that are again evolving from these existing technologies and where people are going with it. So in this case, this is some colleagues, some friends from the Swiss Ornithological Institute that's have this incredible small scale radar, not like the radars that BirdCast is using that are weather surveillance radars, but these are specifically designed to monitor birds, bats, insects at very, very much smaller scales. So the amount of information you extract about individual targets, so not just from the BirdCast perspective, thinking about one pixel being a cubic kilometer of airspace that we're monitoring with lots of birds and lots of stuff in that pixel. In these cases, with these small radars, smaller scale radars, you're actually monitoring individual birds and able to see what their wing beat frequencies are and identify the birds. And in this case, what I wanted to highlight was this idea of using these small scale radars to learn just a little bit more about how birds are responding to not just to light and understanding that it's a disorienting and attractive feature, but what happens when you pair that with other features of an environment in which birds are interacting. For example, coastline versus overland. Birds migrating, having to choose between flying along a coastline and over land or making a jump over water, and what kinds of patterns you see as a result of light pollution in those areas. And one of the striking things about this study, and one of the new elements, is thinking that in places where birds are already pausing, so to speak, where they're making a decision about whether to cross over a body of water, which of course for a terrestrial bird is trouble if you encounter any problems, or to fly around it, or to stop. And in these cases, on nights when there was extensive migration, one of the cool elements we're seeing is this idea of in areas where there's a lot of light pollution, that in these choice areas, birds are slowing down. They're decreasing in altitude. They're actually showing these patterns where the light is actually disorienting them even further than the choices they're making. So it kind of highlights, again, that we already know not all light is created equal, but there are these certain scenarios where light can be even more challenging to birds than it already is. So just kind of highlighting how we're moving the ball forward, so to speak, with studies like this and thinking about cases where even smaller levels of light pollution that may not seem to be terribly problematic for birds may be increasingly so depending on the environment in which you're experiencing that light. If, for example, if it's a coastal area where birds are crossing some kind of water feature, significant water feature, something like the Great Lakes, for example. All right, let me dig into some other patterns. You've seen the eBird graphic before. Each one of these points is an observation from a human, and there are no political boundaries drawn here. This is all observational data plotted on the map, and you can obviously see some interesting patterns right away. The US is very heavily represented, so is Europe, so are parts of Australia. So are some of these incredible transects that people travel in the oceans for various reasons, either research vessels or birding specifically. But the idea here is that there is a lot of information coming in, and increasingly so. Just over, since let's say 2013 was sort of a big year for us when it comes to eBird in terms of the scaling up of the number of checklists and observations submitted every month. It was not long after we started to increase numbers around 2013 that we hit the million checklists per month mark. And now we're closing in on the 3 million checklists per month. The database itself is over 2 billion observations. So just a huge amount of information coming in from all around the planet on where birds are when. So in terms of thinking about new information, the growth of citizen science and the way that birders are out monitoring and how we're able to assemble that information has opened up and unlocked just an incredible array of possibilities. And I want to talk about some of those now in terms of what's new and some of the directions that are coming. And again, some of this work will be from the lab, some will be from our collaborators. And so one cool thing that's come out of it is we have enough data from eBird now to really start to look at patterns over time and to start to think about, okay, we have a 20-year data set where we can start to investigate, for example, looking at eBird observations of a little over 50 species in the eastern US to try to understand how are migrants from the stopover perspective, where they are during the day over spring migration seasons. How does that change relative to what they call green up, or where vegetation is emerging? Basically, where we see blooming inflorescence, leaf out. We call it green up, you call it whatever you want, the arrival of spring, the idea that your primary productivity is occurring and exploding. How does that relate to the speeds with which birds are moving? And one of the really fascinating things is that with earlier and earlier springs, we see that some birds can time their migrations to actually move with that green up. They can almost keep up with it. So this is one of the critical elements of how are birds going to be able to respond to climate change? Are they going to be able to, in a place where maybe they don't have any information at their starting point, say in South America or the Caribbean, to what's happening in Wisconsin or Tennessee or New York, until they arrive in those locations, that there is this capacity for birds to adjust their migration speeds as they get to a particular area and experience what's there. And this study was really, I think, sort of groundbreaking in highlighting that for a large array of species, that these earlier and earlier springs beget faster migration speeds. However, it was very clear from this study also that there is a limit to that. There have been some other corroborative studies that have highlighted that that limit is not only in terms of how fast birds can move, but the energy requirements to do that and the cost of speeding up the movements is high. So birds are not always going to be able to do that, both from the perspective of the speeds with which they fly and the conditions through which they have to fly and how warm a spring is, but also from the perspective of even being prepared to migrate that well, that there's a close relationship between birds having to be in really optimal condition to be able to even do this kind of accelerated migration and to adapt their speeds en route. So fascinating element of how bird migration can adapt, but also the limits of that adaptability and what that means going forward in terms of challenges birds are going to be facing. Also, from the eBird data set, thinking about not just how birds are migrating at a particular place and time, but more broadly speaking about the evolution of migration and how it's maintained and why this process even exists. Some really fascinating work. Ben Winger is an old friend and a colleague, as is Frank Lesort, and the idea that there is this really cool negative relationship between the amount of time birds are on breeding and non-breeding areas, and that there's this trade-off in terms of these two stationary periods of birds' lives when they're in a place and they're breeding, when they're in a place and they're not breeding, corresponding to broadly the northern hemisphere summer and winter. That there's so much information there and so critical a defining variable that it is probably the axis that kind of defines how birds are behaving. So the idea of being able to predict based on how much time a bird spends in its breeding areas and non-breeding areas, how far they're going to be separated, how intense and extensive and long migration is going to be there. Pretty fascinating from the perspective of then thinking about, well, how does migration evolve in the first place and from where? Ben's lab in particular spent quite a lot of time thinking about the various hypotheses that are still not fully proven about did migration evolve in the northern hemisphere, with birds sort of emerging out of there to move south and return north? Did it evolve from a southern hemisphere perspective with birds expanding there as climate refugia sort of became more broad? Really fascinating angles to think about how these times of where birds are spending most of their lives relate to the patterns of migration and the maintenance and evolution of the system in the first place. And by the way, the graphic off on the right there, I can send it around. I know it's relatively small. These are 5 species of thrushes. There's wood thrush at the top, hermit thrush below that, Bicknell's thrush, Swainson's thrush, and gray-cheeked thrush. And the idea that each of these is spending a different amount of time, each of these species, a different amount of time from top to bottom, more time in the breeding season, with wood thrush being the most time and gray-cheeked thrush being the least time. And then also on the other side of things, wood thrush spending the smallest amount of time in the non-breeding areas of Mexico and Central America, and gray-cheeked thrush at the bottom spending the most time in the Andes of South America. So this idea of the relationship between distance and how long birds are spending in breeding and non-breeding areas, super fascinating and new stuff. Let's jump a little bit into one of the fun aspects, that's a little bit beyond the academic piece and still in the half-baked sort of exploratory phase right now. So I want to highlight here yellow-green vireo, really very cool bird, kind of sort of a ubiquitous lurking forest specialist in much of Caribbean, Mexico, Central America, parts of sort of mid-level Andes, Amazonian, northern, central South America. And it's a migrant. And so this is a bird that is a little bit different from obviously the typical boreal migrants we think of that are, say, breeding from, Nova Scotia all the way up to Alaska, and then evacuating those northern lands and migrating somewhere much farther south for the winter. This is a bird that spends its life basically in the tropics, so it's almost always in warm conditions, what we call an intratropical migrant. And one of the interesting things about it is it does rarely work its way into the US. And the places, of course, that you might expect to see this species are generally along the border. Texas has a number of records. You'll see some along the Gulf Coast there. You'll also notice some in California as well, pretty much the southern shield of the US. But there are these really interesting cases, and this is where the notion of the origin of vagrant birds comes in, and sort of the cool explorations we can start to think about, where this species occurs in other places that are much, much farther afield, including as far north as Massachusetts, northern Washington state, Colorado. I mean, really, really bizarre spots for this tropical species to appear, really far, far out of range. And so one of the things that I've been thinking about recently is the relationship between, well, when and where do these birds occur relative to some sort of rather significant climatic patterns that we see. So again, beyond just thinking about the weather of what's happening locally at a particular place and time, but kind of broader patterns that connect the atmosphere and atmospheric patterns that extend over, thousands of miles. And so in this case, I'd like to highlight on the right here, in 2020, there were two yellow-green vireos reported in the beginning of October. And one was seen by a number of people in Cape May, New Jersey. The other, a much smaller number of people just north of Boston. And one of the cool things about what was happening in 2020 when these records were occurred was that there was this unique pattern in the bottom image there. You'll see a sort of interesting shading of darker blues and purples and lighter yellows and greens. I'll explain that a little bit. What we were seeing there is in that area of green and yellow, all of that corresponds to anomalously strong southerly winds, so winds that are blowing from south to north. And when you do the math, and when you look at where those winds are blowing, they are occurring over the Isthmus of Tehuantepec, the Yucatan Peninsula, the Gulf of Mexico, but in particular where over land they're occurring. That Caribbean slope of Mexico and the Yucatan, right in an area where pretty large numbers of yellow-green vireos are at that point. The notion between that southerly flow connecting, as you see in this map, where there's yellow and green, all the way up from the Bay of Campeche and the Isthmus of Tehuantepec and Yucatan, all the way up into northeastern Canada. And when we see those kinds of patterns, we often see vagrancy like this long distance occurrence of a species far out of range. In this case, yellow-green vireos occurring in Mexico and also at the same time occurring way out of range in southern New Jersey and in Massachusetts. And this is one of those patterns that we do see time and again. It's not been well characterized. There are a few studies that have published on it, but this is something that's coming. This idea that we can now extract this kind of information about the climate, like you see below, and do so in a way where we have an enormous amount of data that go far back in time, even to the mid 19th century. And obviously we have some records of birds and specimens that go back that far. So you're going to see in the next couple of years a number of studies that start to focus on vagrancy. And let me keep going with the vagrancy element, because there's some other really cool ways to kind of dig deeper into that. So I was part of a recent study that came out that really it's one of a number that recently have looked at isotopes in feathers. The deposition of certain certain characteristic elements and their forms in feathers that allow us to, because we understand the distribution of those elements around the globe, understand a little bit more about where birds originated. So when birds are captured, for example, on the Farallon Islands, where that little yellow dot is off the coast of California, and they're banded, and samples of one or two feathers are taken from the birds, we can look at those feathers and understand, based on the isotopic composition, where those birds originated. And we can start to understand something about, well, okay, all of these vagrant warblers, for example, in California, all these species that we see in the East all the time, Blackburnian warbler, palm warbler, Tennessee, chestnut-sided magnolia, and blackpoll, all really common migrants through much of eastern deciduous forest in spring and fall. They're super rare in the western U.S. And when they occur, which they do with some frequency, or regularity, I should say, we can now start to identify in these maps, for example, where you see the darker green colors, it's more likely, based on the isotopic signature in the feathers and the isotopic signature in those particular areas, that the birds are originating there. So you're seeing this connection between the western portions of these species ranges where they're normally occurring and where the vagrants are originating. Really, really cool. Definitely very much the future of thinking about exact pinpointing of the origin of vagrants. And then obviously we can think a little bit more, sort of going backwards to what I just talked about before, of how are the birds getting there? What is it that's mechanically taking them there, so to speak? What's the mechanistic approach? What kind of climatology is needed? And then we can dig in deeper in terms of, well, what's needed with the bird's machinery, either to go right or wrong to have that happen. Really, really cool. let's keep going on the vagrancy side, just because it's such a fun one. So maybe some of you have heard recently or seen information about it. There have been some really, really wacky vagrants in the past, even a few months. Bottom left, red-flanked bluetail, small Asian thrush. Bottom right, European robin, obviously a very small European thrush. These species are now both on the east coast of the U.S. One of them is in Virginia, the red-flanked bluetail. There's one in Quebec, in Montreal. And there are some fascinating discussions about, well, what's going on here? In particularly fascinating is for the European robin, there have been a number of cases recently where cruise ships that have docked in Florida and a number of other places have had robins on them for many, many days on the transit from Europe across the Atlantic. So there's this discussion. Well, wait a minute. Are these robins really true vagrants, or are they ship-assisted birds that have just been hanging out on the ships and jump off when the ships land? Or is it, in fact, that something very interesting is happening and that these birds are showing up in these places on their own? We don't know the answer to that for robin yet. There's some evidence that goes both ways. Some cases where clearly birds were ship assisted, where a bird was seen on the ship and then later it was seen near the ship on land, and then it was seen a little farther away. There are other cases like this Montreal bird where it's not so clear that it might actually not be a true vagrant that came on its own accord without assist from some kind of human vehicle. Same thing is true for red-flanked bluetail. This is a bird that's expanding all throughout Asia, and up until probably a few years ago, it was almost unheard of anywhere in North America. But now, as you can see from that map, there are a number of places where the bird has been recorded, including even as far south as south of the latitude below Mexico City. So really interesting things happening when we start to keep our eyes open for these vagrants. And again, thinking about the numbers of people out there observing and the fact that they have cameras to document. And that top image, the common cuckoo, that's another really fascinating one in particular, because common cuckoo is a widespread bird in Eurasia. It occurs all the way from the UK, all the way east across Europe, and almost all the way to Siberia, to the eastern reaches of the western North Pacific. And so the common cuckoo photo on the left was taken in California. The common cuckoo photo in the center was a bird actually that I saw and a number of others saw this fall in New York, out on Long Island. And the one on the far right is a common cuckoo that was photographed in Barbados. So here is a bird where vagrants are probably coming from multiple different perspectives. The origins are different parts of the bird's range, and the birds in the western U.S. are likely from Asia. The bird in the eastern U.S., we don't know. It could be from Europe. It could be from Asia. It could be birds coming over the top of Canada and coming down the East Coast. Could be birds crossing the ocean. And then in Barbados, there's a much stronger case that those are birds in the European African system. So again, fascinating to kind of think, because of this opportunity of people documenting this stuff and being out there, starting to see some of these patterns. Oops. Let's keep going with some other super weird patterns that we're starting to see. I put a question mark down there, not because something is missing, just because it's sort of like, huh? So this array is just almost mind-blowing to me. Birds that are supposed to be in one ocean and show up in the next ocean, obviously with a major landmass in between. Let's go from upper left around clockwise. Short-tailed shearwater. Okay, a very common bird in the Pacific, not common in the Great Lakes or anywhere inland, but in the last couple of years, in particular this past year, short-tailed shearwaters have showed up on multiple of the Great Lakes. Really incredible, like almost unbelievable, but for the wonderful documentation that's happened. Keep continuing around, wedge-tailed shearwater. This is a species of the tropical Eastern Pacific. Not expected to show up in Galveston Bay. Also not expected to show up off the coast of Florida. Very, very bizarre for an Eastern tropical Pacific seabird to show up there. Even stranger, bottom right, Juan Fernandez petrel, a bird from the Central Pacific and also at breeding as far south as some of the isolated islands off of southern South America. That bird was photographed off of Cape Cod earlier this year. And then finally, around to the bottom left, streaked shearwater. Okay, Western Pacific species, quite common in Japan, and in really large numbers, very rare even on the Pacific coast of the U.S. That bird was photographed at point blank range on the ferry between Delaware and Cape May, New Jersey. And so, what's going on here with these cross ocean birds that are, should be in one place but are in another? I think there's some really interesting stories to be told here and sort of cutting edge work to think about. There are cases where, as you'll see in that kind of image, there's a track there where the in the center of the slide, Agatha and Alex. Hurricane Agatha was a Pacific hurricane that crossed over Mexico and then became a tropical storm, Tropical Storm Alex, in 2022. That kind of pattern where we see weather systems that we know and train birds and basically capture them and transport them. Seeing moving from ocean basin to ocean basin, it's likely that's one of the things that's going on here. Also interesting is the notion of, well, okay, there are some other possible avenues that birds can cross over too. What about the Northwest Passage? Increasingly ice-free in some places over the passage of time. That bottom image there, highlighting sort of what the average expectation for the Arctic sea ice extent is, and what it is in blue this year. It's significantly lower, and it's been decreasing each year because of changes in climate that we're experiencing in the Arctic. The openness of that pathway, where there is water instead of ice, allows some of these Pacific seabirds that include short-tailed shearwater, but also other bizarre things like horned puffin and tufted puffin that have shown up in Greenland and in Maine, to get through between the Pacific and Atlantic. So another fascinating avenue to think about. Keep going with one or two more. A fascinating one we're still trying to understand and actually working on right now. Glossy ibis. This is a bird that's distributed in very many parts of the planet, from Australia to all over Africa to breeding in some places in southern Europe, and also into Central Eurasia, also in the parts of the eastern United States. And this is a bird that this year, incredibly, had an enormously productive year in the Spanish Peninsula, which yielded enormous numbers of birds showing up in the UK, which was almost unheard of even 10 years ago, as well as large numbers of birds showing up in Barbados, and birds showing up, as you can see from these sort of almost hilarious images. Bottom left image, that's a glossy ibis landing on a cruise ship, and the person is not very happy that the thing is coming down there. The one above that is on a freighter off of the coast of Guyana. The one in the middle is on an oil, a fishing vessel off the coast of Newfoundland, and the others come from Barbados on the far right. This is one of the cases where we're seeing likely some of the events that probably happened historically that are responsible for the glossy ibis's almost, really kind of bizarre global range, where birds from the African and Eurasian system, very much like cattle egrets and other birds that have come across the Atlantic and colonized in the Western Hemisphere, we're seeing that that's happening now with these birds that are showing up in odd places. But we're also seeing this incredible explosion of birds in Europe, in the Iberian Peninsula. So birds are dispersing into new areas. And we're also seeing that in the US. But exactly what's responsible for this and the connected sort of the dots that we can align here, there are going to be some fascinating ones. It looks very much like it connects to broad atmospheric patterns of where low and high pressure are and what the winds are over the Atlantic, to are there droughts in the Spanish Peninsula? When there's water, there's an explosive population growth in the species. And all of this sort of works into the cycle of where the populations are expanding, where the bird's range is expanding, and then where vagrants are being seen and where they're occurring. So super cutting edge stuff. let me come close to closing. I have a couple more points I want to hit on. I often get this question, what happens to, let's keep going with the vagrant theme. What happens to vagrants? You know, these super rare birds that show up in bizarre places. Um, and the answer is, well, I don't know. You know, based on percentages, well, yeah, a lot of birds may die. Um, Based on birds' ability to move and have wings and use them, they move on. Here are three incredible cases where the same bird, the same vagrant bird, was seen in two crazily different places or more places over the course of time. That kind of highlights to us like, maybe there's quite a lot more, and I need a really good mathematician and statistician to work on this one for sure. This is really half baked at this point. But the idea of being able to think about what does it take in order to detect such a rare occurrence with not obviously perfect coverage of observers in every place you go. Think about the probabilities of encountering a bird in one place or another, and then encountering it again somewhere totally different. There are a number of things that have to connect there to go correctly for that to happen. And I think there's going to be some really interesting research that comes of that. And let me just highlight these crazy cases. So that's a red-footed booby. The picture on the left, so red-footed booby is a tropical seabird, okay? The picture on the left was taken in Maryland, all right? So already like a crazy vagrant for sure. And the next day, that picture on the right was taken in Queens, New York. I'm kind of angry to say that I was away from my apartment. The bird flew by my apartment. It would have been like the most epic apartment list, house list birds ever. And I failed. But a friend of mine photographed it from the top of his apartment. So here is a tropical seabird that's already out of range in Maryland that showed up the next day. Same bird, same individual from analyzing the plumage patterns in Queens. Fascinating, incredible, you know, both from the perspective of where the bird went and more so that two people saw it and documented it. Let's go around to the right. Great Blackhawk. Okay, Great Blackhawk is a tropical American species, really cool raptor, super long legs, does a lot of actually hunting with its legs, goes after amphibians, reptiles, sometimes fish, snakes and things, also other carrion and squirrels and rodents, all that. The top image was a already incredible vagrant photographed in South Texas on South Padre Island in April. Amazing record and beautiful photograph too. The bottom image is that same bird, based on again analysis of the plumage, that showed up in August in Maine. So we're again talking about the same individual that people found it in two wildly different places, 4 to 5 months apart. And then that bird in Maine stayed there for almost 5 months. It stayed way into the winter. Absolutely incredible. And almost pretty much the most incredible of all, I think, is the Steller sea eagle. Some of you may have seen the story about this bird. This is the same individual photographed in 4 different places over the course of 2 years. The top left image of the Steller sea eagle is in Texas. This is a Siberian eagle that does not occur in the US with any regularity. And it showed up in central Texas. As it turns out, that bird also had been in Alaska, the same individual. That bird then 6, 8, 10 months later showed up in northeastern Canada, and then gradually showed up in Massachusetts, went back to Maine, and then ended up in Newfoundland where it is now. Same bird traveling something on the order of, so far, probably 25,000, 30, 40,000 kilometers. Absolutely unbelievable. It made the trip between Alaska and Texas, back to Alaska, across Canada, down to Massachusetts, and then back up to Canada. And this is the same individual, and it's been detected and photographed in all of those places. Absolutely just like unbelievable. All right, so let's move on from vagrancy and just close out with a couple final thoughts here. So, one of the other critical things that we're learning more and more about, both when it comes to migration and patterns of migration, but also where birds are and how populations are doing, is that there are some striking patterns in population declines. I talked about this last time we talked. You probably have all seen the stories about it. One of the really striking and troubling stories is that in cases like this, where we look, you'll see three different columns on the right image there, uh, basically looking at an analysis across a bird's range, looking region by region, and looking kind of at the landscape 15 to 20 kilometer scale, analyzing data in slightly different ways for all of these species. Um, that we're seeing in the areas of red decreasing abundance in a lot of places with population declines. And in fact, when we look at the relationship between the population change over 10 years and where those areas of abundance are, that in areas where the highest abundances are is where the birds are declining. This is a very troubling trend to think about where a species is most common is where it's having the most challenge. It's going to be something that is a serious conservation challenge for the next century and beyond, for sure. And I highlight this because even though we've known for quite some time that bird populations are in trouble, the challenge of analyzing the data and processing information that we have is something we've only recently started to do, and it's really starting to pick up speed with the ability to understand this, and then of course to do some conservation. And I want to end with a positive note here. Some of that conservation includes understanding where do we need to be deploying various techniques and technologies to prevent mortality of birds. This is a really great story. Some of you probably recognize this building from Chicago, the McCormick Place Convention Center, notorious for a lot of glass, a lot of light, and killing a lot of birds. And there was a major event 2 years ago in October that killed almost 1,000 birds on one night at this building. Despite that this had been happening for 40 to 50 years, documented, that was the thing that pushed everybody over the edge to say, this is enough. We cannot tolerate this any further. And the next year, there was a incredible effort, both from conservationists, from Fish and Wildlife, from birders, from the building itself and the people that manage it, to eventually deploy these dots, the bird-friendly technology, the decals that are on the outside of the windows in 2x2 configuration. And that decreased the mortality at these windows by almost 95% in the first season that they deployed it. So there are these success stories where we can start to turn around that kind of nasty, nasty image of, these challenges that birds are facing, whether it's vagrants, whether it's populations, whether it's birds encountering human infrastructure or light pollution, whatever it might be, allowing birds the ability to continue these incredible evolutions and these incredible migrations and so on. So, all right. So I've given you a primer now. I've sort of passed through a number of different things that I think are exciting and coming, some more baked than others. Again, this is all part of work that I do with a lot of colleagues. It's not just me as part of the BirdCast project, but more broadly as part of projects that happen at Cornell Lab of Ornithology. And then, of course, with partners all over. Some of the work here happened at Michigan. Some of it happens at Delaware. Some of it happens at a number of different universities. So all these incredible collaborators and colleagues that are doing this amazing work. So with that, I just want to say thank you. I appreciate the audience. Always fun to debut some new stuff and talk about some things that are kind of like out on the fringe of what we understand and real exploration for what's coming next.
Boy, thank you, Andrew. That was amazing, as usual. So, question I have is you're detecting these birds in movement during migration. You're starting to get some ground truthing or find out what species of birds are migrating. Um, how does the role of these MODIS towers, um, are those just detecting acoustics? Are they detecting just marked birds? And what's their role in all of this?
Yeah, great question. So Modus, I didn't even get to that. That's also super fascinating. And basically think of it as an electronic turnstile. If you're from the East Coast or New York, Easy Pass, Sun Pass, whatever kind of device you might put in your car that allows you to pass through a particular place and it marks that you were there. Modus is very similar. It's basically a network of towers that is detecting some frequency that's coming from a tag that's on a bird or tags that are on lots of different birds or monarch butterflies and bats and bees and all sort dragonflies and all sorts of other things given the miniaturization of the technology. And so this Modus network is when you hear people talking about, oh, I want to put up a Modus station or a Modus tower, it is literally that. It's basically a series of antennas that are detecting a particular frequency range that the tracking tags that are put on individual birds emit. So when a bird passes over one of those antennae, it registers its location. And the more of those that you have, the more you understand about specifically where that bird has gone. And for some of the tags that last a long time on birds, obviously it creates this incredible opportunity to track an individual and see what parts of its route are connected to, where the sanderling that started in, Baffin Bay that passes, through Cape Cod and then jumps to Long Island, and then jumps down to, Turks and Caicos and then ends up in Chile. You can start to make sense of what individual birds are doing. And it absolutely relates to this notion of tracking individuals. And obviously, as you track more, build up sort of, okay, what's this species strategy that's happening here? The more individual information you have, you can understand the variation, you can understand what's consistent among them, how it's changing, what sort of challenging features of a bird's route they're really experiencing versus what we just think we know. Fascinating opportunities, and in particular, even more so because the resolution of these tags now, as we start to use tags that can tap onto the cellular network, makes it so you don't have to necessarily just have Modus stations around. You can use all those cellular towers that are everywhere to localize birds as well. So the resolution of what a bird is doing where and when and exactly its pinpoint position is something now that we take for granted. It's actually doable and it's providing an incredible array of information. And it does absolutely relate to this whole thing about vagrancy. It's just that it's so rare that we actually have a tag on a vagrant bird to understand like where it started and where it's going. It does happen and it has, but it's rare still.
Yeah, thanks. Is there a certain protocol as to where Modus towers are put up or where they're at or where they should be, or is there a grid system that is in place? I've been kind of contacted like, oh, let's put up a Modus tower. Like, I,
Yeah.
you know,
Yeah, it's there's no other than the permissions to deploy it wherever you are going to deploy it. There is no particular organizational structure. Yes, there would be a wonderful ideal grid if you could plan such a thing, but it's not. It hasn't rolled out that way. It's wherever we can get something. That's going to be valuable. And oh, let's target the places where we know there are large numbers of birds migrating, and we want to understand something about birds passing through a particular place and time. So far, the network has largely been driven by who is interested enough to say, you know what, I'm gonna buy one of these things. I'm just gonna put up on my house, or oh, like I really want to help out that project, in Panama or Northern Colombia, and understand like where are these gray cheek thrushes going when they depart here and end up in the Midwest and then in the boreal forest. It's very much driven on a project by project basis. However, there are enough towers now that it's really starting to be quite an incredible network, very dense in some places, so that a bird literally couldn't pass over an area without being detected. It's not that way everywhere for sure, but you can check modus.org is a great source of information for how to get set up, but you don't have to be affiliated with anything in particular in terms of an institution or a project or anything. You can get one on your own if you like. I'm hopefully going to deploy one in Manhattan at some point on my place in the next year. That's part of the plans, and you could do it on your house if you wanted to, for sure.
Interesting. So that's a technology that's going to be around yet. It's still viable. Um, I don't want to put up a CB radio, you know,
Yeah, it's
something
yeah,
that would be
VHS.
outdated or something like
Yeah.
that. So it's
Yeah, like cassette tape or something, right? No, this technology is going to be around for a while, and it's adapting such that having a tower up and then putting a particular kind of antenna that registers a particular frequency from a tracking tag is really easy to adapt. It's very configurable. It's not like when you put this thing up, it's some enormous effort to get it up there and to reconfigure it if you need to. So it can adapt. It's modifiable and but it's going to be a long time before the basic technology of what you're actually tracking, what frequencies changes. So it's something you can definitely feel like if you make the investment, it's going to be around for a while. Not like beta or VHS tapes anymore.
so. I'll give somebody else any questions here from the audience here. And
We're gonna go through these questions here.
okay, we can go through the online ones.
Yeah,
Andrew, can you see them?
I see them. Yes. Let me let me go through and see. First, let's start with the forest gilding and the assemblages that we see in the day, let's say during stopover or breeding. Do we see that pattern also in nocturnal migration? We do sometimes see that, but we see other really odd patterns too that are very different than that. So we might see, okay, yes, that magnolia warbler and red start and a couple of others are often traveling together and often might be found in the same forested patch, for example. But we also see these patterns of, like white-throated sparrow and common yellowthroat and savanna sparrow and palm warbler species that are in very different breeding habitats, but that are all migrating together. So we're still teasing apart exactly when those patterns change and blur together and when they stay constant. But you do see some pretty regular patterns. For example, we're starting to see with the acoustic data. Well, for example, like in the fall in New York, when you detect an American redstart, it's very likely you'll also detect a black and white warbler and a northern parula and an ovenbird. They all tend to be migrating together at the same time and using the same kind of strategy and may occur within like a few minutes of one another in an audio recording at night. Let's see. As far as pelagics, the discussion about particular breeding colonies like Midway and tourism we haven't seen a very good connection yet with the dispersal of birds and trouble on colonies, challenges on colonies yet. But that's certainly something that even if it's not tourism, but it's, for example, rats and cats and other invasive snakes and things that decimate or really alter the behavior of breeding seabirds in particular. I suspect that could be something that clearly distributes where birds are when. We haven't seen it yet and haven't pinpointed it yet, but really, really good question. Um, Climate change, though, when it comes to seabirds, yes. And sea surface temperatures, yes. And things like El Nino and the Southern Oscillation and where warm and cold temperatures are in the ocean, and anomalously so, and where the food is as a result, that absolutely is an impact on where birds are and when vagrant seabirds occur in particular, because they have to move out of a particular area where there's suddenly no food because the water is 10 degrees warmer than it usually is. Let's see, habitat loss, drought conditions. Yeah, that's a fascinating one. And seeing in particular changes in patterns in water birds as a function of obviously where water is. Dramatic connection there often between where water birds are and where drought is occurring and the movements of those birds for sure. Sometimes it's a little bit difficult to pinpoint specifics because, well, when droughts are often that extensive, there's a tremendous amount of movement of water birds away from those areas. But it also happens with other species too, like dickcissel, right? Drought conditions are very much indicative of Is it going to be a poor year for dick thistles? And are they going to move somewhere where there's a lot more moisture? Kind of lends itself to species that are very much nomadic. You see this pattern in Australia all the time, where there's water, and when there is water, birds are breeding en masse and are ubiquitous and incredibly abundant. When that water disappears, so too do the birds, and it's almost like they just fade into the background. Really, really cool and fascinating. I see that somebody was lucky enough to see the Stellar sea eagle, which was named Stella in Massachusetts. That's awesome. Very, very cool. Yes, a final one about the interaction, sort of the protection of airspace, if you will. The push to erect these higher and higher structures that are often more illuminated and more encased in glass, as well as relating that to how birds interact with those, how that affects, for example, patterns with flight of birds and flight of aircraft, and the ability to change the infrastructure being built with some really smart science and some great advocacy and some big grassroots support, that it's doable to make some of these incredible changes happen. And we can now support it with the science, and really simple science, actually, that's very easy to talk about. That's like one sentence science almost, that then can lead to very simple actions that then also connect to other positive things, like whether it's why are birds valuable ecosystem services, they bring in a ton of dollars to our local economy, they de-stress people, they have a right to exist, etc. And oh, by the way, decreasing light pollution is good for humans and saves energy, and moving so that we understand what flight patterns of birds are so that we can alter patterns at the airport. Okay, that's going to save dollars and lives too. All of these things tend to become related, and I think it's a wonderful time. It's not wonderful in the number of challenges that we have. But it's a wonderful time in terms of our capability to do really amazing stuff with our minds and our technology and our science and our mobilization of people and resources to try to do the right thing and to try to be more sustainable. So I'm glad to hear that happened in Boston. It's happened in New York. It certainly happened in Texas. It's happened in Chicago, lots of places. There are some good stories out there too. We hope to kind of promote those more as we can. We hear a lot of bad news. There's definitely some good news too.
So the last call for questions, either from the audience or online. There again, Andrew, wow, it's just mind-blowing. And that's what's so fascinating to me is birds, migration. You wake up one morning and I had a summer tanager in my yard. Like, why is there a summer tanager here?
Yeah.
And a couple of years ago, we were fortunate enough to catch um, 5 American flamingos on the shore of Lake Michigan.
Oh yeah, I remember.
It's Yeah, I mean they're rare to Florida, and like, are you kidding me? It's like I'm not much of a chaser. But I looked at my wife and I says, "What do you think?" And she said,
Let's go.
"Let's go."
There you go.
And it was a magical sight because we got there, school was just letting out, and and it was at near a power plant at Port Washington, and there was a cop directing traffic, and I thought, oh my God, did somebody get hurt or something? One of these school kids, cross the street, and it was everybody that was going to see these flamingos. There was hundreds of people on the beach.
Yeah, it's incredible, right? It's an amazing thing. Absolutely amazing. Yeah, it's going to be this is really fun stuff. As I said, there's an endless array of exciting and new things. I just touched on a couple, obviously, and happy to talk about more. As I said in the chat, I'm happy to share the presentation just because it is, there's stuff in there. You're welcome to digest it. I'm happy to feel free to email me. We can talk about it anytime, and there's always more to say. So I appreciate the audience, your audience with this and all your questions. Thank you, and thank you for having me again.
Everybody want
Thank you.
so with that, we're going to sign off. And thanks again.
Take care. Happy New Year.
You too.
Have a wonderful. Take care.